H2O supports Causal AI in many ways with Driverless AI as well as H2O3. A typical example is with Uplift modeling, where the goal is to evaluate the uplift between a treatment group and a control group. Driverless AI allows also to create a stratification check on the treatment and control group, ensuring that both groups are randomly selected and are of similar population behind. Those models can be created in Driverless through the use of custom recipes, which are available on our public repository. Namely, we have LightGBM for Uplift, XGBoost, GLM, as well as a custom scorer, the area under the Uplift curve that can be used in Driverless AI. In H2O3, we have the Uplift random forest, which is used for Causal AI. Once the Uplift Driverless AI recipe have been uploaded to Driverless AI, this can be used into an experiment. Let's have a look. Here, we've uploaded both LightGBM and transformer outcome and XGBoost transformer code as models, as well as the area under the Uplift curve scorer. Here, our target column is the response, trying to understand whether, for example, a customer has positively responded to a campaign, could be for a purchase, for example, and the weight column, which is the treatment group. In our case, for example, whether or not the specific customer has been targeted by a campaign. Our goal here is to get the net prediction of responding positively given a treatment has been made versus a control. Let's launch it. And now let's have a look at the same thing into H2O3. H2O3 offers to its user the distributed uplift random forest, or Uplift DRF, which is available in the Python library or directly into the user interface called H2O Flow. There's multiple examples online of the use of the Uplift random forest modeling that is available to the user to understand how those library compares with, for example, the Causal ML library. Let's have a look into H2O Flow. Here, I have the same data than in Driverless AI. I have my response column and I have my treatment column here. Let's now create a model using Uplift distributed random forest. I can select the training frame here. I can select the response column. I can ignore some columns that are not of interest. And I can select the treatment column. In our case, MMS campaign. Let's build the model now. Once the model has completed, the user can have now a look at the output, in particular the variable importances, for example, so the variable that are more likely to discriminate the people likely to respond positively to a treatment versus people that are not, as well as some output from the training matrix. In particular, this is relevant for the user to find the optimal threshold to target the actual customer or users for a specific treatment. Next, the user can predict the model on new data or existing data and looking at the output. It can combine it with the original frame, all of it to obtain a data set like this, where both the uplift prediction, the prediction of responding positively given a treatment or without a treatment, and the actual uplift here. Likewise, in Driverless AI, once the experiment has completed, the similar output are available by applying a prediction on new datasets.